Hey math kids, today we're going to talk about logarithmic functions, and we're just going to jump right in. So we're given f of x is equal to log base 2 of x minus 1 plus 1. And it wants us to first state the transformation, which maps y equals log base 2x to y equals f of x. Okay, so this is really just kind of some notation. But really the only thing that's going on is this is going to move us to the right one, and this is going to move us up one. And so when we talk about that, we write it like this: f of x is a translation of y equals log base 2 of x by 1, 1. So this is vector notation. The top, it's like an x and then a y. So it's basically saying it's shifting in the positive x direction 1 and the positive y direction 1. So that's to the right 1 and up 1. Okay? So it's not really a hard concept. The notation's new though, so that might be confusing. Okay, part B says find the domain and range. I actually think it's easier to sketch it. Like, they eventually want you to sketch it like later, but I think sketching it first is helpful. So just a regular log function looks like this, and we have a vertical asymptote on the y-axis, and we cross at 1. So that would be like the graph of just this, log base 2 of x. Now, if we're going to go up 1, right 1, this point, for example, is going to go up 1, right 1. So now that point is right there. Or here, actually I'm going to do that a little bit different. Let's just talk about the right one for a second. So if we just move it to the right by 1, this is now at 2, and we now have a vertical asymptote at 1. Now, if we shift that up by 1, this point now goes here. We're not going to affect the vertical asymptote, but it's going to cross a little bit earlier because we moved it up 1. So we don't really know the x-intercept anymore. We just know that it's in between 1 and 2. But that's roughly the graph. And so if we're going to look at the domain is going to go from, it's just everything that's greater than 1. And the range goes all the way down, all the way up. So it's all real numbers, like that. All right, now it says find any asymptotes and axis intercepts. So asymptotes, we know right now, we have a vertical asymptote at x equals 1. We can see that from our graph. And then axis intercepts, we don't have a y-intercept, but we do have an x-intercept. We just don't know what it is. Now to find an x-intercept, we're going to plug in 0 for y up here. And then we're going to solve doing this. Okay, I feel like I need more room, so let's get rid of this. Okay. So if I'll just rewrite that. So we're going to subtract 1. So we get negative 1 equals log base 2 x minus 1. Now to undo a log base 2, we need to do a big 2 on both sides. So we get 2 to the negative 1. These cancel, equals x minus 1. Now, 2 to the negative 1 is just 1/2, because it's like I brought it down to the bottom. If I add 1 to both sides, I get 1 plus 1/2, which is 3/2. And so the x-intercept is at 3/2, which is exactly halfway between 1 and 2. We didn't know that from the graph, even though my drawing looks pretty close to that. We just knew that it was somewhere in between. Okay, so we have an x-intercept at 3/2, and we have a vertical asymptote at x equals 1. Okay, it asks us to sketch the graph. We already did that, so we're going to move on. And then we're going to find the inverse function. So, to find the inverse function, I'm going to get rid of this because I'll need some room. Okay, so that's a 2. To find the inverse function, we think of the f of x as a y, then we swap the x and the y. And then we want to solve for y. So we subtract 1, subtract 1. So x minus 1 equals log base 2 of y minus 1. To get rid of log base 2, we do a big 2 on both sides. So we get 2 to the x minus 1 equals y minus 1. And then we just add 1 to both sides. 2 to the x minus 1 plus 1 equals y. And then we want to change our notation to f inverse of x is equal to 2 to the x minus 1 plus 1. Alright, if you need additional help, please come to Math Lab. Until then, calculator.